Hello, everyone, and welcome back to our second part for building high performance and resilient microservices. In this training, I'm going to let you know that what the Saga pattern is and how many types it has and how each type is working and what are the pros and the cons for the each type. But before we deep dive in that detail, let's understand a problem context first. So you must be aware about the acid properties in RDBMS. So if I take atomic from the acid properties, then all the operations in a transaction are treated as a single unit. It means that if one operation fails, then the whole transaction is failed. And if all the operations successfully completed, then the data is saved permanently in the database. What if we would like to achieve the same functionality in a distributed transaction scenario where you have distributed databases and you would like to treat them as a single unit? So the most common way to solve that problem is the two-phase commits or the two PC commits. It has two different very simple phases. In phase one, it prepares the data, and in phase two, it commits or the rolls back the data on the basis of what the status it is getting. So let me explain you the phase one. So in phase one, we have a coordinator, and that coordinator sends the request to the participant one that whether the transaction can be commit or not. If it receives the response in yes, then a coordinator acquires a lock on the participant one, and for the participant two, it follows the same step and acquires a lock. And this is how your phase one is completed. In phase 2, which is the commit or the rollback phase, if everything goes fine with your participant A and participant B, then your logs are released on the database and your data is saved permanently in the database. But what if any of your participant fails, then your whole transaction is rolled back. So you don't need to implement that logic from the scratch because there are already some tools which are providing you that facility. For example, Atomicos or the Zoop or the Apache Zookeeper are already providing you that facility with very simple implementation. So there are some disadvantages with that approach. One is the blocking issue. If the coordinator fails during the commit phase, all participants remain blocked, waiting indefinitely for the decision. Second disadvantage is single point of failure. The coordinator into PC commit is a very critical component, and if it fails, the entire transaction process is jeopardized. And third one is the performance overhead. The protocol introduces high latency due to multiple communication rounds, impacting system performance. Two phase or two PC commit will be very useful pattern. But when we talk about microservices architecture, where we specifically implemented database per service pattern, then it will be challenging for us to implement two PC in that microservices architecture because managing the state of the data in a distributed transaction is complex by itself. So Saga pattern simplifies that problem for us. So Saga pattern is a design pattern for managing distributed transactions by breaking them into smaller transactions, and each transaction has its own compensation logic for rolling back the partial failures. So there are several advantages of Saga pattern. So one is that we can split the long-lived transaction into smaller steps. Other is each step comes up with its own compensation logic and compensation action, decentralized coordination across the services, and then the resilient to the partial failures. There are two strategies to implement the Saga pattern. One is the choreography and other is the orchestration. Saga can be more resilient and flexible as compared to 2PC, but it requires a careful configuration and design. So let's understand this by order service example. So for example, you created an order and you subtracted the inventory from your store against that order, and you made the payment, and from your payment service you issue the call to your payment gateway. And for some reason, if your payment fails, then there is no use of subtracting the inventory or keeping the order intact in your system. So Saga pattern compensates the transactions to maintain the consistency of the data here. Because Saga pattern breaks down the order service into the smaller local transaction, and each transaction executes a single task at a time and communicates through the events with each other. So in this example, order service is a one local transaction, and if order is successfully completed, then the order completed event is triggered, and if order failed, then the order failed event is triggered. And the same case with my inventory service, so which is my local transaction too. And if inventory is completed, then inventory completed event is triggered, and it if it fails, then rollback events is triggered, and same case with my payment service as well. Let's have a look on architecture diagram for the order service in Saga Orchestrator. Saga Orchestrator is a central control which sends the command to the each participant to execute the required actions. And once it issues the call to the participant, then it waits for the response. And if it receives the response from the participant 1, then it issues the call to the second participant. And if it receives the response from the second participant, it issues the call to the next participant subsequently. And for example, if your any participant fails, then Saga Orchestrator executes the compensation logic for the each participant accordingly. And if I talk about the choreography in Saga, then there is no any central control, and every microservice reacts to the event. And if any error occurs, then the compensation logic is executed by the other service. And the operation in the choreography is done asynchronously in each microservice. So orchestrator is very easy to implement and easy to debug, and there is one single point of failure because you know that in which sequence your services are going to call each other, or in which sequence they are going to compensate the transaction. On the other side, in choreography, you have the better scalability, you have the loose coupling and the asynchronous communication. And if I talk about the cons for the orchestrator, then there is a tight coupling because every service is depending upon your central control, which is the Saga orchestrator. And it is very difficult to add and remove the microservices because you have to reorder everything in the orchestrator in order to add and remove any microservice. And if I talk about the cons on the choreography approach, then there is lack of central control and difficult to troubleshoot. It depends upon the choice and the requirement of your project that which pattern you are going to apply. In next demo, we will implement these two patterns.